Hi sir, this is the complete model of PV battery inverter. So as I already discussed this part with you and this part with you. Now I changed the controller because the first one gave me some problems in tuning. So I replaced that with the PI controller instead of fuzzy logic controller. So you can see the logic of the controller. It will generate two signal, one for charging, one for discharging. It use the V boost voltage and compare it with the V reference that we give it 400 watt. So based on this, it gives us the IB reference current that we will compare it with the battery current. So both current will give us an error signal that will be fed to PID controller and that generate a duty for us. So that duty will be then passed to the PWM generator and they will give us two switching signal that will complement each other. When one is on, the other will off. So at a time, if let's suppose SP is a switch, so in that case, the buck operation will be performed and the boost will be off. Buck operation means that the battery will charge. In the second case, if SN is on or true, then the boost operation will be on and buck operation will be off. In that case, it's mean that the battery is discharging. When the battery will be charging, will be the battery discharging. That's an other like control system. But let assume that when there is a power available from the PV system, it will charge the battery. Otherwise, it will discharge the battery through the load. Also, we have an inverter that we use for our system is universal bridge inverter. When you double click on this block, you will see here the specification of the universal bridge we used. Here we use number of bridges OM2 because we are using it for residential purpose. In residential purpose, we mostly use edge bridge. So I suppose that our load is residential, so I choose it here too. If you are using three-phase system, then we will use it three. Here the universal bridge generate the output which is not favorably sinusoidal. It gives us the output which is a square wave PWM output, or you can say that modified output. For that purpose, we use LCL filter, which will convert the square wave to a sine wave so that our load cannot be damaged, especially the electronics load. PWM also work for inductive load, but when it's come to electronics, that may not be a good option. So for that purpose, we use this LCL filter to convert the modified wave to sine wave. Then here is the load, resistive and inductive load. Normally in home we have two types of load: inductive, which include fans, water pumps, and resistive loads include LED bulbs, heating, etc. So then we use it as an RMS, and that give us a 220 approximately, which will not be exceed from 230. Also, one thing I want to point out to you is that we have two types of universal bridge. One is diode based and one is IGBT based. When it's diode based, then no gate signal is required. When it's IGBT based, then you will have to generate a gate signal similar as we generate for the boost converter here. Similar we generate here for the uh, bidirectional converter, and similar we generate for the inverter. So based on that gate signal or PWM signal, the inverter decide when that will be on or when they'll be off. Basically, it's provide a switching signals or switching frequency. So that's all from my video. If you have any question, you may ask me in WhatsApp. Thanks for your time and wait. Have a good day.